Okay, 50 years wanted to run through corrections for the homework I'd posted or the work that I'd asked you to get done on Monday. So, question 1, question 7, question 14, question 17, question 19. Now, question 19 I've read over again, and a couple of people sent me emails saying that they had problems with it. I've had a look, I've had a go at it myself, and there seems to be some kind of issue with the final part. So, I can do the top 3 bits with you if you want to. I'll post them another time. I'll just write up written answers and I'll post them to you. But I'm just gonna go 1, 7, 14, 17 today. So question 1 is here, and the arithmetic sequence. All we're asking for the start term, which is term A, the common difference, which is term D, and the general term then, or Tn, or the nth term. So I have done 3 parts for you in this problem. I did part 1, I did part 6, and I did part 7. Okay, I picked those ones. 1, because you've got a regular positive sequence there. 6, you've got negative values, so I wanted to do that one. And with term 7, the value is decreasing, so I wanted to show you just an example of all of those ones. So you'll see term 1, 5, 7, 9, 11 is the first one up here. Okay, so that's our term. I've got my start point is my A value, 5. Got my common difference, so the difference between each term is plus 2. You can notice that I put in the sign, plus 2 for D. So now I have A and I have D, and I'm going to use that to fill in to get the Tn, or the general term. So I fill in my A value for 5, I fill in my D value for 2, I multiply 2 by everything inside that bracket. So I've got 2 by n gives me the 2n, and 2 by minus 1 gives me the minus 2. So I'm left with that, and I just tidy that up. I've got 5 minus 2 gives me 3, and usually we put our algebraic term first. So that's the way to do it, okay? Nice and simple. So I just wanted to show you the same for a couple of more. You've got this one with negative terms. So minus 12 is my first term, but to get from minus 12 to minus 7, I'm actually adding 5. So I've got plus 5 as my common difference. So again, I fill them into my general term formula. Got the minus 12, I got the plus 5, multiply out my bracket, and I tidy it up, and that's what I got as my answer. And then finally, I've got this sequence down here for part 7. 43 is my start point, and the term is going, or the sequence is going down, so we're minusing 3 each time, or subtracting 3. So that's my common difference. My common difference is minus 3, so I've got to pop that into the formula as minus 3, as you can see. So I got my 43 in as my A, and I've got my minus 3 in as the D value. Again, multiply that out and tidy it up, and I end up with my general term. Okay, so that's question 1 done. Nice and straightforward, I hope. Question 7 then. It says we've got this as our arithmetic sequence. Find the nth term and write down the 21st term. So same process. I'm looking for Tn first and foremost, and then I'm going to use Tn to figure out T21. Okay, so I'm going to have this done on the next slide. We've got our sequence. I've got my A value, I've got my D value, pop them in to find in my Tn. So we've done that in the previous question, so I don't want to run over that quickly again. You can see it there and you can check it yourself. And then I want to do T21, because it's asked from the 21st term. So I use my general term, minus 6n plus 37, and I substitute in my n value as 21. So you can see that goes in where n was, minus 6 by 21 plus 37, and that gives me minus 89. So the 21st term in this sequence is 89. As I've written down here, alternatively, what we could do differently, if we didn't want to do it that way, we'd figure out my common difference is minus 6, and you could just list the sequence. So you could just take away 6, 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 and keep doing that all the way down until you do it, till you get to the 21st term. You just count them out, 1, 2, 3, 4, 5, till we get to 21, and we can get our answer as minus 89. So you can see that that's the same, and they're both correct. Now, There's no difference in doing those ways. You'd still get full marks down here if you did it like that. However, imagine that they asked you for the 500th term. If they asked you for that, you'd be doing this method for a very long time. So I would strongly urge you to go about doing it the way I've done up here. Get your general term, and then fill it into the formula based around what term that you're looking for. So that's that. Question 7, done. 14 then. The nth term of some sequences are given below. Write down the first 4 terms and then decide whether the sequence is arithmetic or not. So with question 14, I just did a couple of examples. I did 2 of them. I did number 1 and I did number 5, because that one has got a fraction in it and I wanted to show you that one specifically. So what it's asking you to do in A, very simply, we're asking to get T1, T2, T3, T4. Alright, so we do that, and then we have to substitute in. I have a formula for Tn, and I want to subtract Tn minus 1. And I've done that in 2 ways, and you'll see it in my calculation in a minute. Okay, a little bit of explanation to be doing on this. So we can see here, I've got my general term, 2n plus 1. So I'm going to substitute in n for 1, n for 2, n for 3, n for 4, and I get my values, 3, 5, 7, 9. Now you can see from there that this is an arithmetic sequence because it's going up in 2 each time, no hassle. But to prove it, I suppose we need to see. Okay, you can see I've done it 2 different ways here. I've done it like this, and I've done it up here in this box as well. So I want to show you both. First thing I've done Tn minus Tn minus 1. So I took one of them. So imagine I took T4, and the one before that, Tn minus 1, would be T3. So I just did T4 minus T3, and that gives us 2, which is a constant. Okay, so 2 is just a number, is a constant, and therefore I can say that the sequence is arithmetic. Now, just to add to that, I suppose I would have to do this more than once. Okay, I would have to do T3 minus T2 as well and repeat that, and I should get the same answer, and I would get the same answer in this case. And if you show me that it is a constant, then that 2 is the thing that keeps cropping up as the difference between 2 consecutive terms, then that does prove that the sequence is arithmetic. To make sure not to be really, really careful on this, I would go about it doing it this way. You know, it's a little bit trickier, but it does make sure that we're clear. Okay, you can see I'm using the general term. I've got 2n minus 1, which is Tn, and then I used Tn minus 1. So you can see wherever I was going to write n, or wherever I did write n here, I wrote n minus 1 in. Okay, and you can see that they are subtracted. So I've got 2n, I'm just going to rewrite it up here because it's a bit clearer. 2n plus 1, and then I've got minus 2 by n minus 1 plus 1. So you can see the only thing that's different between this line and this line is that the n is now n minus 1, okay? And I'm subtracting them from one another. So you'd multiply out those brackets and so on, and you'd end up with that you can see there. I've done for you. I've got 2n plus 1 minus 2n plus 2 minus 1. So when I multiply all that out and get rid of all those brackets there, I end up with that. The 2n and the minus 2n cancel, and that's the most important part, because if I'm left with n, if there's any n value left in here, if there's any n value left, that shows me that it's not a constant, not equal to a constant difference, okay? So all I'm left, I've got plus 1, plus 2 is plus 3, minus 1. So my difference here is 2. Now I know that if we go back I've got my T1 to T4. It goes 3, 5, 7, 9. So the common difference is plus 2. And I knew so that's right. Okay. Now, the reason that I had to show you the two ways to do this is because when it comes to a fraction, it's a little bit different. I've done it. I've got my first term, my second term, my third term, my fourth term, no worries. But if I do it like I showed you originally here, I end up with a numerical value. You could argue that that's a constant, therefore that is an arithmetic sequence, but that's not the case, okay? Because you can see that the difference between here and here is not the same as between here and here, and not the same as between here and here. Because that's a 1, then a half, then a third, then a quarter. It's getting smaller, but it's not getting smaller by the same amount each time. So what I've done, as I said, I did Tn minus Tn minus 1, like we were expected to do, or asked to do in the question. My Tn, my general term, is 1 over n. So Tn minus 1 will just be 1 over n minus 1. As you can see, got my common denominator. We did loads of that in the last couple of weeks, and we end up with this. Okay, now again, it has an n in it, so therefore it's not a constant. Okay, so it's not an arithmetic sequence. Finally, question 17. And this is where we had to do our simultaneous equations. Again, something that we practiced for a long while. So I've got term 11 and I've got term 50. It's asking me to find A and D first and foremost, and then find the general term. So let's have a look. So I've got my term 11, I've got my term 50. I can fill them in to the general term formula. I can put that equal to 17 for 11 as my n value, and I can put that equal to 95 for 50 as my n value. So you can see I've worked out two equations. A plus 10d equals 17, and A plus 49d is equal to 95. I then use those as simultaneous equations. The way I've done it, I've changed the top one, I've changed equation 1, changed all the signs along the bottom, cancel those as you can see, and we end up with that then when I bring the two terms together. I've got 39d is equal to 78, and I work out the d value to be 2. So I know now that d is equal to 2. I can use that d value, I pop it back into the original formula, the first one that was given to me, and I solve for a, and I've got then an a value and a d value. So you've used the simultaneous equations to do that. Again, it's all there for you. Pause it, have a proper look if you want to, and then we just fill it in to the general term like you guys did for me yesterday. So we're all good. So that's it. Okay, thank you.